Done, sir.
Done. Okay, then we will try the next question. Next is in each of the following, determine whether the statement is true or false. Okay, if false, if true, prove it. If it is false, give an example. So first is if X belongs to A and A belongs to B, then X belongs to B. Okay, we need to check whether this is true or false. So we will take an example. Let A is equal to 1, 2. B is equal to 1, 1, 2, and 3. Okay. Now, Savan, please tell me that this 2 belongs to 1, 2. This is correct or not?
Correct, sir.
And 1, 2. 1, 2. Can we say this belongs to B?
Yes, sir.
Okay. So, because we have this set in B. So can we say that A belongs to B?
Yes, sir.
However, 2 does not belongs to B. Okay. Hence it is
Yes.
false.
Yes.
So what was the statement? X belongs to A. If we take an element which belongs to A and A belongs to B, then this element should belongs to B. So what we have done, we have taken a value 2 and this 2 belongs to 1, 2. And we have shown this that this complete A. Okay, A belongs to B.
Yes, sir.
Okay.
Understood.
Okay, very good. So Safan, please note down this, then we will
Yes.
start the next one. Please confirm me once you note it.
Yes.
Done?
No, sir. One second.
Okay.
Done, sir.
Okay, Safan, so we will take a second one. Second is if A is a subset of B and B belongs to C, then A belongs to C. Okay, Savan, can you tell me this is true or false? Okay, not a issue. We will take
True.
example. True. Okay, we will take example. A is equal to 2. B is equal to example. Okay, B is equal to 0, 2. And C is equal to 1, 0, 2, and 3. Okay, then Safan, this is correct. Can we say A is a subset of B?
Yes, sir.
Can we say B belongs to C?
Yes, sir.
Now, can we say that A belongs to C? This is true or false?
False.
This is false. Okay,
Okay.
very good. A does not belongs to C. Please note down this, then we will start third one.
Done, sir.
Good. Safan, please tell me the third one. This is true or false?
False.
This is true. A is a subset of B is a subset of C, then A is also a subset of C.
So
Okay.
how?
Let's take example, but after the example, we will prove this also, because in the question it is mentioned that prove it if this is true. Okay, so just give me a minute. So for example, we have this A, which have the value 1. We have B, which have the value 1, 2, 3. We have C, which have the value 1, 2, 3, 4. Okay, so A is a subset of B. This is correct.
Yes, sir.
B is a
B.
subset of C. Then A is also a subset of C.
Yes.
Okay, so this is true. So we need to prove this. So how can we prove it? Let A is a subset of B and B is a subset of C. Let X belongs to A. So this means, this implies X also belongs to B, because A is a subset of B. This implies X is a subset of C, B, because B is a subset of C. So this means, therefore, A is a subset of C. There is a value of X which belongs to A. So this also belongs to B. This also belongs to C. So this means the value which is present in A also present in C. That's why we will say that A is a subset of C. Okay, Safan?
Yes, sir.
Okay, so please note down this and confirm
Done.
me. Okay, good. Next one. So Safan, when you have your exams?
So next week Sunday.
Next week, Sunday. Okay. So if A is not a subset of B and B is not a subset of C, then A is not a subset of C. This is true or false?
True.
This is true. Okay, we will take example. A is equal to 1, 2. B is equal to 0, 6, 8. And C is equal to 0, 1, 2, 6, and 9. Now, can we say that A is a subset of B?
No.
No. Can we say B is a subset of C?
No.
No. But A is a subset of C. Is correct?
Yes, sir.
So if this means if A is not a subset of B, B is not a subset of C, then this is not necessarily true that A is also not a subset of C. Okay?
Okay.
Please note down this and check the fifth one. So fine, please tell me this fifth one is true or false. So this is what, if there is an element which is there in A, but A is not a subset of B, then this value will be present in B.
Yes, sir.
This is true. Okay, we will take example. A is equal to suppose 358. B is equal to, and B is equal to suppose 3, 4, and 6. Now 5 belongs to A, and A is not a subset of B. Okay, 5 belongs to A is not a subset of B, and however, 5 does not belongs to B. Yeah, there is a value which is there in set A is not a subset of B, then this value does not belongs to B. So this is false. Okay, so far.
Okay, sir.
Okay, please confirm me once you note it. Then we start next.
1 second, sir.
Okay, okay.
Done, sir.
Okay, next one. Then sixth. Sixth is if A is a subset of B and X does not belongs to B, then X does not belongs to A. Okay, so if A is a subset of B and there is a value which is not there in B, then that value should also not be present in A. So this is true or false?
False.
This is true.
Okay.
Suppose we will take example, then we will prove it. There is 1, 2, 3. Okay, and we have this B, which is 1, 2, 3, 4. Now there is a value, for example, 5, which is not there in B. This value is not there in B. So will this present in A or not? No, because A is a subset of B. All the values which are present in A should be there in B because A is a subset of B. So if there is a value which is not there in B, then this will also not present in set A. This
Okay,
clear?
sir. Yes.
Okay, good. So just we will prove it. Let A is a subset of B and X does not belongs to B. To show X belongs to A, we need to show this. If possible, हम opposite let करते हैं. If possible, X suppose X belongs to A, then X belongs to B, which is contradiction, as X does not belongs to B, therefore X does not belongs to A. So what we have done in this question, we have assumed that A is a subset of B and X does not belongs to B, and we need to show that X does not belongs to A. So what we have done, we have supposed that we have assumed that X belongs to A. Now if X belongs to A, then X also belongs to B because A is a subset of B. Now we are telling that this is a contradiction. Okay, in class 10, Safan, do you have done the problem where you need to prove that root 2 is a irrational number?
Yes, sir, but I don't remember.
Remember, so in such type of cases, what we do, we assume a wrong thing, and after that, a contradiction arises. Okay, so whenever a contradiction arises, then we say that this was not true. So what we do in this case, we have assumed that this value belongs to A. Now, if this belongs to A, then this belongs to B. But this is a contradiction because already we have said that X belongs to B. X does not belongs to B. That's why this is a contradiction. We will say that X does not belongs to A. Okay, Safan?
Okay, sir.
So these types of problems are very difficult. These problems from question number 2 to question number 11. Okay, but we need to do this. Please confirm me, Safan, once you complete it.
1 second, sir.
Okay.
Done, sir.
Okay. So Safan, always remember you have an objective paper MCQ based. So
Yes.
whenever you have a doubt in any question, these proof type of questions, you can easily check that with a Venn diagram. Okay. So in NCRT, we need to prove this. So we will do. But in case in exam, if you got stuck, then please draw the Venn diagram and try to solve the question. So we will try the third one. Third is let A, B, and C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Then show that B is equal to C. Okay. So this is given that A union B is equal to A union C, A intersection B is equal to A intersection C. Now we need to show that this B is equal to C. So we will start with this. Let A, B, and C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Okay, so A, B, C, B set such that A union B is equal to this. We have assumed this one and this one. Now, what we need to show? To show B is equal to C. We'll start from here. Let X belongs to B. So this means X belongs to A union B. This is true or false? If X belongs to B, then it should belongs to A union B or not? Safan?
Yes, sir.
For example, if you have a value 1, 2 and you have value 2, 3, 4, what is A union B?
1, 2, 3, 4.
1, 2, 3, 4. Safan, I know this is boring and difficult, but we need to complete all these questions up to 12.
Yes, sir.
Okay. Now, if suppose there is a value, for example, 4 belongs to B, then 4 also belongs to A union B, because in A union B, you have all the values which are present in A and B. So if
Yes.
there is a value which is there in B, then it should present in A union. Okay. So what we have done, we are saying that this X belongs to B. That's why this should belongs to A union B. Okay. Why? Because B is a subset of A union B. Now this implies X belongs to A union C. Why? Because A union B is equal to A union C. This A union B is equal to A union C. So if X belongs to A union B, it should also belongs to A union C. Okay, Safan?
Yes.
So this means X belongs to A. So this means X belongs to A or X belongs to C. This correct?
Yes, sir.
Now, X belongs to A. Also, X belongs to B. So X belongs to A intersection B. This means X belongs to A intersection C. So A intersection B is equal to A intersection C. So please note down this. I will again explain to you from the beginning.
Done, sir.
Okay. So okay, first we will do some more steps. So X belongs to A intersection C because A intersection B is equal to A intersection C. This means X belongs to A and X belongs to C. So this means X belongs to C. So therefore B is a subset of C. Now similarly, we can show that C is a subset of B. Therefore, B is equal to C. So what we have done here, in this case, we have checked this. X belongs to A or X belongs to C. This we have assumed that X belongs to A and X belongs to B. So this means X belongs to A intersection B because the value is present in A as well as in B. Okay. So now if X belongs to A intersection B, then X also belongs to A intersection C because A intersection B is equal to A intersection C. Now the value of X is present in both A and C. That's why we are saying the value is belongs to A and C. Value belongs to C. Now here we have assumed that X belongs to B. And here we are saying that X belongs to C. So if a value which is present in B is also there in C, then this means B is a subset of C. Safan, understood?
Yes, sir.
Uh, did you understood this question?
Yes.
I don't think so. So please note this, Safan, and try to check all the steps. And if you have any doubt, then please let me know. Okay, these are complicated questions from this 2nd to 12th. Everyone face problem with this question. Okay.
Okay, sir.
After this, today only we will start the relation functions. That is much better than these questions. Okay.
Okay, sir. Done, sir.
Now the next question is show that the following four conditions are equivalent are equivalent. Okay, so the first is A intersection B. Second, sorry, A is a subset of B. Second is A minus B is equal to null set. Third one, A union B is equal to B. And fourth one, A intersection B is equal to A. Okay, so we need to show that these conditions are equivalent. Please note down this question, then we will start.
Yes, sir. 1 second. Done, sir.
Okay, so one, just give me a minute. Okay, so for this question, first, let A is a subset of B. Okay, to show A minus B is equal to 5. Okay, so what we will do, we will assume this as the opposite. We will assume it, if possible, suppose A minus B is not equal to the null set. This means that there exists X belongs to A and X is not equal to B. Sorry. A minus B is not equal to the null set. So this means there are some values in A which does not belongs to B, which is not possible, as A is a subset of B. So this is given A is a subset of B. We need to show that A minus B is equal to the null set. So what we have done, we have assumed this as the opposite, that A minus B is not equal to a null set. So it means there is any value in A which is not there in B. Okay, so which is not possible because A is a subset of B. So this is not possible. That's why, therefore, A minus B is equal to Y. Okay, therefore, A is a subset of B. This implies A minus B is equal to 5. Okay, now what we will show here, first we have to show that one. Okay, so what does this mean? If first is true, then this implies second is true, and this means second is true, then first is also true.
Okay, sir.
Okay, so we have proved this, that if A is a subset of B, then A minus B will be equal to the null set. Now we will assume opposite, that this is true. Now we will show this one second. So someone please note down this, then we will start the question.
Done, sir.
Okay, now on the second one, we will assume this, let A minus B is equal to 5. We will show A is a subset of B. Okay, let X belongs to A. Now clearly X belongs to B, because if X does not belongs to B, then A minus B is not equal to null set. We need to show this A is a subset of B. Now let X belongs to A. So X should also belongs to B, because A minus B is equal to null set. Therefore, A minus B is equal to null set. This implies A is a subset of B. Therefore, first, so whenever first is true, second is true. Whenever second is true, the first is true. That's why this is okay. Okay, so first and second are equivalent. Please note on this, then we will start the next one. Safan, please confirm me once
Done,
you
sir. Done.
okay. So we have proved this one. Okay. Now second, we have to show first, whenever first is true, then third is true. Okay. So we will, what is the first one? First we have this, and third is A union B is equal to B. So what we need to do, let A is a subset of B to show A union B is equal to B. Clearly. Safan, this is the last question of this chapter. Then we will start the relation function, and in the next week, we will do the remaining questions.
Okay, sir.
Okay, I know this is very boring. So in every class, half an hour, we will try to do these questions.
Okay, sir.
So clearly B is a subset of A union B. A is a subset of B. We need to show that A union B is equal to B. So B, we already know that B is a subset of A union B. Safan, please note this.
1 second, sir. Done, sir.
Okay, Safan. Let X belongs to A union B. This implies X belongs to A or X belongs to B. We'll take a case 1. X belongs to A. So this means X belongs to B, as A is a subset of B. Therefore, A union B is a subset of B. Now case 2, we will take X belongs to B, then A union B is equal to B. Okay, and conversely, let A union B is equal to B. Let X belongs to A, X belongs to A union B. Okay, since A is a subset of A union B. So this implies X belongs to B. A union B is equal to B. Therefore, A is a subset of B. Hence, 1 is true, so third is true. And whenever third is true, then 1 is true. Okay, so Sufan, please note down this. Sufan, please confirm me once you know it.
Done, sir.
Okay. Now the last one. Now we have to show. Now we have to show. Now we have to show that first 4. Okay, let A is a subset of B. Clearly, A is a subset of B. So let X belongs to A. We have to show X belongs to A intersection B as A intersection B, X belongs to B. So X belongs to A intersection B. Therefore, A is a subset of A intersection B. Okay, and conversely, suppose A intersection B is equal to A. So let X belongs to A. X belongs to A intersection B. This implies X belongs to A and X belongs to B. This implies X belongs to B. Therefore, A is a subset of B. Hence, whenever 1 is true, then 4th is true and vice versa. Okay, so Savan, today we will do only these questions. In the next class, we will do next 4 questions.
Okay, sir.
Okay, so please note down this and confirm me, then we will start a new chapter, relation and functions.
Done, sir.
Okay. So, Safan, we will start the new chapter, relations and functions. Okay, so in relation and function, first of all, we will check the ordered pair. Ordered pairs. Okay. So what is ordered pair and ordered pair? And ordered pair consists of two elements. Consist of two elements or objects in a given fixed order. In a given fixed order. Okay, Safan, this clear?
Yes, sir.
Okay, so what's the ordered pair? Just for example, when we write like this, x comma y, so we know that first is the x coordinate and second is the y coordinate. So in ordered pair, we have two elements which are arranged in a fixed order. So for example, this one. Okay, this is a very simple thing. There is no need to further explain it. So please note down this, then we will check the next one. Safan, shall we start next?
Yes, sir.
Okay. So next is equality. Next is equality of ordered pair. Equality of ordered pair. Okay, so what is this equality of ordered pairs? Suppose we have two ordered pairs, x1, y1, and this is equal to x2, y2. So when we say that these two ordered pairs are equal, when the first element is equal to the first element of this, second element is equal to second element of this. Okay, Safan?
Okay, sir.
So when two ordered pairs are equal, when the first element of this is
Yes.
equal to first element of this is equal to second of this. So the question is find x and y. Find x and y if x comma y x comma 2 is equal to 3 comma y. Okay, Savan, please try this question and tell me the answer.
X is equals to 3, y is equal to 2.
Very good. Please try the next question. Find a and b. Savan, please find the value of a and b.
A is equals to 1, B is equal to 0.
Very good. This is correct. Okay, good. So next we will start the Cartesian product. Okay. So next is Cartesian product. Cartesian product of sets. Let A and B, let A and B be two non-empty sets. Be two non-empty sets. Let A and B be two non-empty sets. Then the set of all ordered and the set of all ordered pair A comma B such that A belongs to A and B belongs to B is called the Cartesian product of A and B, and it is denoted by A cross B. So A cross B is what? This is A comma B. What is A? A belongs to A. And what is B? B belongs to B. Okay. Safan, please note this. This is a very simple concept, simple topic. Please note this. We will take example. Safan, please confirm me once
One
you.
second.
Okay.
Done, sir.
Okay. So what is a Cartesian product? We will take example. Suppose we have a set A that is equal to 1 and 2. And suppose we have a set B which has the value 3 and 4. Okay, we need to find the Cartesian product A and B. This is read as A cross B. So what we will do, we will select an element from the first set. We will select the next element from the second set. Again, element from first set, from second set, from first set, from second set. So this is the Cartesian product. This clear, Safan?
Uh,
Okay. We need to
yes.
find A cross B. So what we will do, we will select the first element from the first set, the next from the second one. So 1 comma 3. Again first, next one 1 comma 4. Again 2, next one 3. Again 2, next one 4.
Understood, sir.
Okay. So Safan, can you tell me then what is B cross A?
B cross A.
Yep.
Uh, 3, 3 and 1, 3
3,
and
1.
2,
Very
3,
good.
1, 3, 2,
Very good.
4, 1, 4, 2.
Very good. 4, 1, 4, 2. That's correct. 4, 2. Okay. Okay. Safan, number of elements in A cross B is what? 1,
4,
2, 3,
4,
4. Number of elements in A? 2.
2,
Number of elements in B?
2,
So 2 into 2 is 4.
4.
So if we need to find the number of elements in A cross B, then what we will do, we will find the number of elements in A. We will multiply that with number of elements in B. Okay, Safan. So
Yes.
if you wish, okay, then please note this. And this example is your choice. If you wish, you want to note this.
Done, sir.
Done. Okay. Then we will try a question from NCERT. Question is, if the set, this is second question of NCERT first exercise. If
Okay.
the set A has 3 elements and the set B and the set B is equal to 3, 4, 5, then find the number of elements, then find the number of elements in A cross B.
9.
A has 3 element, B has 3. Very good. This is 9. Very good. Next question number third, first exercise. If G is equal to 7, 8 and H is equal to 5, 4, 2, find G cross H and H and H cross G. Please complete this effort.
Done.
Okay, Safan, so what's the answer?
7 5 7 4 7 2 8 5 8
Mhm.
4 8 2 2 7 2 8 4
Mhm.
7 4 8 5 7 5 8.
Very, very good. Next, try question number 5th. If A is equal to -1, 1, then find A cross A cross A. Okay, please try this. Otherwise, I will help you.
-1 1.
-1, 1. Okay, the next.
Uh, m- -1.
Safan, what we will do first,
-1. Yeah.
first of all, we'll find A cross A. Okay, so A
Okay.
cross A means we have the same set
Yes.
and we are finding its Cartesian product. So this is what we will
-1 -1.
-1 will good. Next one, -1, 1,
1
then 1
1
minus 1,
1 -1 1 1.
1, 1. So this is A cross A. Now what we will do with A cross A.
A.
So first element with this and with this one. So -1, -1, and then the third one, -1. Okay. Next is -1, -1 with the next one, 1. Next, -1, 1 with this -1. Next, -1, 1 and 1. Next, select this 1, -1, -1, 1, -1, 1, 1, 1, -1, 1, 1 and 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 2 into 2, 4, 2, 8. Okay, this clear, Safa?
Yes, sir.
Okay, so first we need to find A cross A, then this element with the first element, then this, sorry, this with the first element, this with the second element, and so on. Okay, please note down this, then we will start the next one.
Done.
Okay, then Safan, please try next question. Next is
So which exercise?
first exercise. Okay, 2.1. The Cartesian product
Yes.
has 9 elements. among which are found -1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. Okay, please try this question. If you will face any issue, I will help you.
So again, so
Yes. So this is the Cartesian product A and A has 9 elements, okay, among which are found this. So A cross A has 9 elements. So can you tell me, Safan, that how many elements are there in set A?
3.
3, very good. So A cross A have this -1, 0, 0, 1, and there are some other elements. Now, this first value will belong to the set, okay? So this should be -1. Okay, Safan?
Yes, sir.
This first value belong to first set. So this is 0.
Okay, sir.
Now this 1 belong to which set?
Second, sir.
Same. Second is also the same one.
0.
Only this one, -1, 0, 1. 0 is already there.
Okay.
Okay. So set A have 3 elements. So we get this. Now again, the second set is also the same one. This correct?
Yes, sir.
Now we find the set A. Now you need to find the remaining elements of A cross A. So please find the 7 elements, remaining 7 elements, and share your answer.
Done, sir.
Done. Okay, so fine. What's the answer?
Oh, -1, -1, -1, 0, -1, 1, 0, -1, 0, 0, 0, 1, 1, -1, -1, 0, -1, 1.
Okay, very good. So remaining 7 elements you have found. Okay, so Safan, in this chapter we have 3 exercises. First is based on the Cartesian product. Okay, that topic we have done. There's other questions in the same topic. So please try to do the first exercise. Okay, and please try to complete the homework for the sets as well as this, because now we have very less time left.
So
And
what was the homework for the sets?
for the sets, the complete one, exercise 1.1 to 1.6 plus miscellaneous.
Okay, so
Okay, 1.5 is not in our syllabus, so there's no need to do that.
okay, sir.
Okay, and we have very less time left, so please complete the homework so that we can finish the maximum syllabus on time.
Okay.
Okay, now we will start the relations. This is the topic from the second exercise. First is completed. Please try to do that. If you have any doubt, we will discuss in the next class. Now, relation. A relation, what is a relation? A relation, is a subset. A relation is a subset of Cartesian product. A relation is a subset of Cartesian product. The subset is derived by describing a relationship. Okay, a relation is a subset of a Cartesian product of two non-empty sets. Okay, we will define that sets are non-empty of two non-empty sets A and B. The subset is derived by describing a relationship between set A and B. So what is a relation? A relation is a subset of Cartesian product of two non-empty sets A and B. The subset is derived by describing a relationship between the first element and second element of the ordered pair. The second element is called the image of first element. Okay, so we will take example to better understand the definition. Okay, so what is a relations? For example, if we have a set A having the elements 1, 2, and we have another set B which have the elements suppose 3 and 6. So we will first of all find A cross B. So A cross B, this will be equal to 1, 3, 1, 6, 2, 3, and 2, 6. Okay. This is a Cartesian product. Now, what is a relation? Relation is a subset of Cartesian product. So we will choose some values from this. Okay. And how can you form a subset? So subset is formed by describing a relationship between the first element and the second element. So here we will give a condition that both the numbers are even. Both the numbers are even. So which elements we will select? We will select only 2, 6. So for this case, our relation is only 2, 6. Okay. So what is a relation? Relation is a subset of the Cartesian product. How can you form that subset? Depend on the condition. Okay. You always have some condition according to which you need to form the relation. So find this clear. What is a relation?
Yes.
What's a relation? It is a subset of the Cartesian product. How can you form that subset? By giving a condition, by giving a relationship between these two elements. Okay, Safan, what is a relation?
Relation is a subset of a Cartesian product.
Subset of Cartesian product. How can you find that subset? By describing a relation. By describing a relationship between the first and the second element of the ordered pair. Okay, so Safan, please note down this. Then we will try some questions and we will try to better understand this, that what is actually a relation. of the ordered pairs. Okay, just add 1 point of the ordered pair in A cross B. Please confirm me once this is done so that we can start some questions. Safan, please confirm me once you complete it.
Done, sir.
Done. Okay. So please try this question. Let A is equal to 1, 2, 3, so on up to 14. Define a relation R from A to A by R is equal to x comma y, 3x minus y is equal to 0, wherever xy belongs to A. Okay, so we need to find a relation. So as we have already checked that what is a relation, it is a subset of Cartesian product. And how can we find that subset? By describing a relation. So here they have given that condition. Okay, so what we need to do, R is equal to, so in place of x and y, what can you put? You can put these values 1, 2, 3, and 40. It's your choice, but the value should satisfy this equation. So we have this one, 3x minus y is equal to 0. Now, Safan, put this value of x from this set. Put x is equal to 1. So can you tell me what the value of y you will get?
3.
1, this is 3, very good. When you put x is equal to 2, then what y you will get?
6.
6. When x is 3, what is y?
9.
When x is 4, what is y?
12.
When x is 5, what is y?
15.
15. 15 is there in the set?
No.
No. So we will not take this. Okay. Because x, y both should belongs to A. Here 5 comma 15 is not there. That's
Okay.
why this is only the relation. Okay, Safan?
Okay, Sanders.
Okay, very good. Then please note down this. Then I will give you another question. And Safan, please leave some lines after this question because we need to find the domain and relation, domain and range also. So please
Okay.
leave 3-4 lines after this. Next is define a relation. Define a relation R on the set N of natural numbers by R is equal to x comma y is equal to x plus 5. X is a natural number less than 4. X, Y belongs to natural number. Okay, so we need to find a relation. So what is the relation? Y is equal to x plus 5. X is a natural number less than 4. Okay, so Safan, please try to do this and tell me the complete ordered pair.
So if x equals to 1, y is 6.
X is 1, Y is 6. Okay, next one.
2, then y is 7.
Y is 7, X belongs to natural number. Okay, next.
3, then 8.
Very good. Any other
4,
value? Can we take 4?
no.
No.
X is less than 4, yeah, no.
Okay, so this is the relation.
Yes,
Okay, and then please leave some lines after
okay.
this.
Okay.
So fine, please let me know once you complete it. So fine, this done.
1 second.
Good.
Done, sir.
Okay. Next, Safan, we will do the representation of a relation. We have done that. How can we find a relation? Now we have a different method of representing a relation. Representation of a relation. Okay. So the first method is roster form. We have already done the roster form in the set. The same concept is there in the relation. So what is the roster form? In this form, a relation is, in this form, a relation is represented by the set of, is represented by the set of all ordered, by the set of all ordered pairs belonging to R. Belonging to R. So what is the roster form? The previous question which we have solved. This is the roster form. Okay. So what we need to do in roster form, we write all the ordered pairs. Okay, Safan? Safan, this is clear?
Yes, sir.
So there is no need to explain further this. We already know that what is a roster form. You just need to write all the ordered pairs in this. Okay.
Yes, sir.
Next, second is arrow diagram. Arrow diagram. Okay. So what we do in this, in order to represent a relation from set A to set B, set A to set B, in set B, by an arrow diagram, we draw arrows from first component from first component to the second component to the second component of all ordered pairs of all ordered pairs belonging to R. Okay, so definitions are lengthy, but you can easily understand that what is arrow diagram. So for example, if we have a set A having the value 1, 2, 3, 4, and we have a set B having the okay, so having said this is suppose 6, 7, 8, 9, and we have this relation which is suppose this is 2, 6, 2, 8, 4, 6, and 4, 8. Okay, on some basis we have selected this relation. Then how can we draw an arrow diagram? You will draw a figure like this, and this is set A and this is set B. Okay, and set A write all the values 1, 2, 3, 4, and set B write all the values 6, 7, 8, 9. Now 2 is related with 6, so join this like this. 2 is related to 8, join like this. 4 related to 6, join like this. 4 related to 8, like this. So far this is clear?
Yes, sir.
Any doubt in roster and arrow diagram?
No, sir.
Okay, so what we do in the roster diagram, roster form, we just write the element. What we do in the arrow diagram, we draw a figure like this, we write the
Yes.
elements and we connect them with
Fine.
arrows. Okay, so
Yeah.
Safan, do you want to continue or shall we start the next topic in the next class?
So next class.
Next class, okay. So, but you need to complete the homework.
Okay, sir.
Okay, so in sets, I have already told you that what's the homework. For
Yes.
relation and functions, exercise 2.1 complete. Then 2.2, question number 1 and 2 we have done. Just try to do question number 1 to 5. Okay, and there are some parts which we have not completed yet, so that we will try in the next class.